Hello everybody. In this lesson we are going to study about statistics, some of the fundamentals of statistics which you have already studied in your lower grades like mean, median, mode. In this lesson we will study about how to find the mean of grouped data. So welcome to the lesson. In your lower grades, say class 9, you have studied the classification of given data into ungrouped as well as grouped frequency distributions. You have also learned to represent the data pictorially in the form of various graphs such as bar graphs, histograms, and frequency polygons. In fact, you went a step further by studying certain numerical representations of the ungrouped data, also called measures of central tendency, namely mean, median, and mode. In this video and our forthcoming videos, we shall extend the study of these three measures, that is mean, median, and mode, from ungrouped data to that of grouped data. We shall also discuss the concept of cumulative frequency, the cumulative frequency distribution, and how to draw cumulative frequency curves called ogives. So make sure that you watch this video as well as my forthcoming videos on this lesson. Now let's turn our attention to finding out the mean of grouped data. The mean or average of observations, as we know, is the sum of the values of all the observations divided by the total number of observations. And you have studied in your lower grades, if you can recall, that if x1, x2, xn are observations with respective frequencies f1, f2 and so on till fn, then this means observation x1 occurs f1 times, observation x2 occurs f2 times, and so on. Now, the sum of the values of all the observations will be equal to what? So the sum of the observations of all the values will be equal to f1 times x1 plus f2 times x2 and so on till f1 times x1. This will be the sum of all the observations. And the number of observations will be f1 plus f2 plus so on till fn. You add the frequencies. So the mean x bar of the data is given by the sum of all the observations divided by the number of observations. L represents the middle terms which come in between. So how do you find the mean? The sum of all the observations divided by the sum of the observations frequencies. So recall that we can write this in short form also by using the Greek letter sigma, which means summation. So we can use the sigma symbol, the Greek letter, sum of the observations divided by the sum of frequencies, going from I equal to 1 to n. We can still write this in a more shorter form by x prime, the mean, is equal to sigma fi xi divided by sigma fi, where I starts from n. It varies from 1 to n. So this is how we have learned how to find the mean of the observations. Let's try an example based on this concept. Let's try this problem. The marks obtained by 30 students of class 10 of a certain school in mathematics paper consists of 100 marks are presented in table below. Find the mean of the marks obtained by the students. So we know the number of students, 10 students, number of students, 1, marks obtained, 10. One student got 20 marks, 3 students have got 36 marks, 4 students have got 40 marks, and so on. So this represents the number of students, the frequency of students who have obtained these marks. So what if you have to find the mean? We know Fi, we know Xi, we need to find the product of this, and we need to add them and the number of frequencies. Let's redesign this table and write it in a vertical form for easy calculation. So the columns will be marks obtained, number of frequency, number of students, and the product of the frequency and the marks obtained. And what do we get? We can list them: marks obtained, number of students, and the product of Fi times Xi. We need to total this. So what do we get? So the frequency is, we know the sigma symbol is 30, and when you add this, you get 1779. Now how do we find the mean? It is this divided by this, which is 1779 divided by 30, and that is 59.3. So the mean of this table is 59.3. So the mean marks obtained is 59.3. So in most of our real life situations, the data is usually so large that to make a meaningful study, it needs to be condensed as grouped data. So we need to convert given ungrouped data into group data and devise some method to find its mean. Let us convert the ungrouped data of the example 1 in grouped data by forming class intervals of width, say 15. For example, now when we group the data into class intervals, so we will have the marks obtained from 10 to 25, marks obtained between 25 to 40, 40 to 55, 55 to 70, 70 to 85, and 85 to 100. So we have now grouped the marks obtained in the intervals of 15. But remember that while allocating the frequencies, this one, the frequencies, to each class interval, students falling in upper class limit would be considered in the next class. For example, look at this. Let's take how many students have scored marks 40? It is 4. Now if you observe the class intervals, there are two groups here, 25 to 40 and 40 to 55. So how many students scored marks 40 and above, between 40 to 55? It is 7 students. We will put them in the upper class, the next class. We will not put the number of students who got 40 marks in this class. We will put them in the next upper class. So the number of students who scored 40 marks and above, between 40 to 55, will be 4 plus 3, that is 7. The number of students who scored marks between 25 to 40, 25 to 40 will be 3 students. And the number of students who scored from 10 to 25 will be 2 students. Because one student scored 10 marks, one student scored 20 marks. 3 students scored 36 marks. So now do you understand how you distribute the number of students in this class interval? So we have represented the ungrouped data in the form of a grouped class intervals. Then we have put the number of frequencies. Now, for each class interval, we require a point which would serve as the representative of the whole class. So some point which is going to represent each class. It is assumed that the frequency of each class interval is centered around its midpoint. The frequency of each class interval is centered around its midpoint. So the midpoint of each class, which is also called as class mark, can be shown or can be chosen to represent the observations falling in that class. So the midpoint of this will be the representation chosen to fall within that class. Recall that we find the midpoint of a class or class mark by finding the average of its upper and the lower limits. So how will you find the class mark? We will find the upper class limit plus the lower class limit divided by 2. For example, let's take this class interval. The upper class limit is 10, the lower class limit is 25. The lower class limit is 10 and the upper class limit is 25. So find the average of that. That's going to be 10 plus 25 divided by 2, which is going to be 17.5. So the class mark of this class interval is 17.5. Similarly, let us find the class mark for each class interval and put them down in the table. So we have the class intervals of 15 each. We have the number of frequencies. We can find the class mark. How did we find that? Taking the average of the class intervals. 25 plus 10 divided by 2, 17.5. 40 plus 25 divided by 2, 32.5, and so on. So we get this column. Now how do we find Fi times Xi? We take the product. 2 times 17.5, 3 times 32.5, and so on. Now we can total this column and this column. Let's see what we get. When we total that, you get, it is simple arithmetic basically. You need to know the method of finding these things. So number of frequency is 30. That's going to remain the same irrespective of the class interval. Then the product Fi is this time 1860. Now we know how to calculate the mean. This divided by this. And what is that going to be? 1860 divided by 30, which is 62. This new method of finding the mean is known as the direct method. So from ungrouped data, we have grouped the data in the form of class intervals. We took the class mark by taking the average of this class interval. And then we multiplied the frequency with the class mark to get this. We added this and this. And we divided this with this to get the mean. This is called direct method. Did you observe that in the previous table, say 14.1, and now in this table 14.3, we are using the same data and employing the same formula for the calculation of the mean. But the results obtained are different. Remember the result that we got, the mean that we got from the first table? It was 59.3. The mean that we got from here is 62, although we are using the same formula. Why is this so? And which one is more accurate? The difference in the two values is because of the midpoint assumption in this table 14.3. 59.3 being the exact mean, while 62 an approximate mean. Sometimes when the numerical values of xi and fi are large, finding the product of xi and fi becomes tedious and time consuming. So for such situations, let us think of a method of reducing these calculations. Let's keep this table once again in front of us. We can do nothing with the FIs, the frequencies over here, but we can change each XI to a smaller number so that our calculations become easy. How do we do this? What about subtracting a fixed number from each of these XIs? Let us try this method. The first step is to choose one among the XIs as the assumed mean and denote it by the letter A. So we will choose one number amongst this and as an assumed mean, and let us denote that by the letter A. Also, to further reduce our calculation work, we may take A to be that XI which lies in the center of these values. So we can choose A to be either 47.5 or we can choose A to be either 62.5. Let us choose A to be 47.5. So the first step, let us choose one of the values of Xi as an assumed mean and let us represent that by A. Let's take the middle of these. It can be 47.5 or 62.5. Let's settle down for 47.5. The next step is to find the difference D between A and each of that XIs. That is the deviation of A from each of the XIs. So we will now find the difference of each XI with A, and that is going to be XI minus A, and A we have chosen to be 47.5. So this is called the deviation of A from each XI. So 17.5 minus 47.5, then 32.5 minus 47.5, we will get the deviation here. Then we will get the deviation here, which is obviously going to be 0. We will get the deviation here and here and here. So let us put that in the form of a table now. Then the third step will be, after listing down all the DIs, subtracting from 47.5, we get DIs. Then we take the product of FI times DI. FI times DI, we get this. 3 times negative 15, we get this. 7 times 0, we get this. So we find FI times DI. Then we find the sum of FI DI. We already know the sum of the frequencies. This will not change. Now we can find the mean of the deviations, D, by this divided by 30. This is the mean of the deviation. It is not the mean. So we need to find the relationship between the mean and the deviation now. Now, in order to find the relationship between the mean x bar and the mean of the deviation D, what did we do? Since in obtaining D, we subtracted A from each xi. So in order to get the mean x bar, we need to add the A to D bar. So then the mean is going to be A plus sigma Fi di over sigma Fi. So now we already know the values. We know what this is. We can calculate from here. And we know what was A, the standard mean deviation. And we can plug it in and find the values. What was A? The middle of the XIs which we took, which was 47.5. Remember that? This was the mean deviation, the deviation for each XI. So we can plug in A and plug in the values and find the mean. So when we plug in the values for A and D bar, we get this. 435 over 30 plus 47.5. Simplify that and you get 62 as the mean. This method of finding the mean is called the assumed mean method. So we know how to find the mean of the ungrouped data. Now we found the mean by the grouped data by direct method and also by the assumed mean method. Let's look at the table once again. Look at the values of D. Are all these values divisible by 15? They are. We can simplify this further, reduce the size of the numbers further so that when we multiply with F, multiplication becomes easy. So since D, all the numbers are divisible, the whole column is divisible by 15, and 15 happens to be a class interval. So we can generate or reduce the size of the numbers by dividing di, that is x minus a, by the class interval h. So let's see what we do. So let ui be equal to xi minus a, that is nothing but rd, divided by h, where h happens to be the class size. We will add this column over here and see how our table looks like. So when we find u, we get this column. Now it becomes very easy for us to find f times u for each row. And we take the total of that. We know the frequency. We can easily now calculate u bar. Now we need to find out the relationship between u and our mean. So let's find the relationship between the u and x bar over here, and that is a plus h times u bar. A is the deviation that we have taken. U bar is what we got by the deviation divided by the class interval, and h is our class interval. So what we get over here now is a plus h times, we already found out what is u bar. We can now plug in the values, and that's going to be a is 47.5 times h, the class interval is 15, and we already found out this 29 over 30, and you get 62. Look, the mean is the same in all the three cases. This method of finding u bar and then finding the mean is called the step deviation method. So we have found the mean of the grouped data by the direct method, by assumed mean deviation method, and by step deviation method. You can apply any method you like, the mean will still remain the same. The only thing is which method to choose depends upon the size of the numbers, which will make it easy for us to multiply. So take your choice, look at the numbers and see which are the numbers that are easy to multiply, and then go for the method of your choice to find the mean of the group data. So I really appreciate the effort that you have put in understanding this lesson, and thank you very much for watching this video. Please do share and subscribe to this channel, Wisdom Outlined. Thank you very much.